Basic terminologies which are used in rheology. The first one is force. Force, it is nothing but a push or a pull which is going to act on a body. Here in the image we can see here it is a push, means it is also a force which is going to act on a body. And another one is a pull. Here the body is pulled in this direction. Here also we are applying the force, so that is called as force F. The shear stress, which is represented by this symbol, and it is called as tau. What is shear stress here? The force which is applied per unit area. Means here we are going to apply the force per unit area. Means how much force is applied per unit area. Means at a particular specific distance how much force is applied. So here is the equation, that is tau is equal to F divided by A. Here tau means shear stress, F means force, A is equal to area, and the unit which is used to measure this one is dyne per centimeter square or Pascal. Important terminology is strain. So it is represented or denoted by gamma. So strain means what? The deformation produced due to applied stress. So what is deformation? Deformation means change in shape or size of the material. Change in shape or size of the material. Why this change in shape and change in size happens? Because of applied force. Here in this diagram we can see the force is applied on this material, and here due to that force the shape and size of the substance or material is get changed. That is called as deformed state. That is what about deformation, and it is represented by equation lambda is equal to gamma is equal to L into lambda divided by L. Here is the equation, gamma is equal to L into lambda divided by L, and it has no unit. There are different types of deformation are there. That is, deformation means what? When the force is applied to any substance, it will changes in its size and shape. That is called as deformation. Alright, so how many types of this deformation is there? That is, the solid material undergoes how many types of change in shape and change in size? The first one is elastic deformation. Here when the force is applied and force is removed, then the material returns to its original shape and size. Means, for example, here we are taking rubber. So when the force is applied on this material, so it undergoes what? It undergoes deformation. After, when we remove the force, again it will comes back to its original shape and size. So here we can see in the diagram, here there is no force, the material is present as it is, but when the force is applied, what happens? The material undergoes a reversible deformation, that is change in shape and size, which is when we are going to remove the force, the material will return back to its original shape. So this type of change in shape and size, that is, this type of deformation is called as elastic deformation. So which material shows this type of property? Means rubber. Plastic deformation. So here this type of deformation is permanent deformation. Means when the force is applied to the material, it undergoes deformation, that is change in shape and size, but will not come back to its original shape and size when the force is removed. So that is called as plastic deformation. Here we can see the material is there, we are applying the force to this material, so here it will changes its shape and size, but when the force is removed, it will not come back to its original shape and size. The best example is clay. Rheology is fluidity, means how easily the liquid is undergo a flowing, or how ease with which the liquid flows. So it is reverse or inverse to the viscosity. Means fluidity means as the liquid is more fluid in nature, the movement or the flow of the liquid is more. As the fluid is less, as the liquid is having less fluidity, then the movement is also very less. So here we can see low fluidity, especially high viscous liquid like oils. Okay, here the movement or the flowing of the fluid is very less because there is a less fluidity, and here the liquid which is having high fluidity, and it will move or flows very fast as compared to the viscous liquid because the viscosity is very less. So here we can see the equation. The fluidity is represented by this symbol, it is called as phi is equal to 1 divided by n. So where phi means what? Fluidity, n means viscosity, and here is the point to be remember is when the viscosity increases, the fluidity decreases. When the viscosity decreases, the fluidity increases. That is, the fluidity is inversely proportional to viscosity. Means Newtonian flow. Means what? Here the flow where the viscosity remains constant even we are applying the force or shear rate. So means here the liquid is going to move and the viscosity of the liquid will remain constant, even we are applying the force, okay, shear rate. For example, the liquids which are showing this type of movement is water, alcohol, glycerin and simple solutions. So here in the diagram we can see in the y axis we have taken the shear rate, and in the x axis we are taken the shear stress. So here even though we are applying the force or whatever, the shear rate is going to increase, but it will not going to affect the viscosity of that liquid. The viscosity will remain same as it is, constant. Now the non-Newtonian flow, that is the viscosity is going to change with the applied stress. So what happens in the Newtonian flow of liquid? Here the viscosity remains constant at Newtonian flow, but in non-Newtonian flow the viscosity changes with applied shear stress. So here we can classify the non-Newtonian flow as follows. The first one is plastic flow. So what are the characteristics in this type of flow is it requires yield value to start a flow. Means here it is the liquid, to move this liquid or to flow this liquid we require at least a minimum amount of force. So that minimum amount or starting of that or you can say the minimum amount of the force which is required to cause the flow of this liquid is called as yield value. That is the minimum force which is required to move this or to cause flow of this liquid is called as yield value. So the flow starts only after certain stress. So here we can see the rheogram, or you can the graphical representation. Here in the one side we have taken the shear rate, and other side we have taken the shear stress. So here is the yield value, means the minimum force is required to cause the flow of liquid. Example for this type of flow, or you can say the liquids which are showing this type of flow is the flocculated suspensions and toothpaste and ointments. And here another type is pseudoplastic flow. It is the shear thinning system where the viscosity decreases as the shear rate increases. Means when we apply the force to the viscous liquid, okay, what happens? The viscosity is going to decrease. The viscosity is going to decrease when we apply the force or shear stress to the liquid. As the shear stress increases, the viscosity decreases. So this type of flow is called as pseudoplastic flow. So this type of flow can be shown by these materials when they are mixed with the liquid, that is the tragacanth, methyl cellulose, sodium alginate. Okay, here pseudo means what? Thin on shaking. So when we shake the bottle which is containing the viscous liquid, means we are applying some force. What happens? It will loses its viscosity. And another type is dilatant flow. Here what happens? When we apply the force or shear stress to the liquid system, instead of decreasing the viscosity is going to increase. So but what happens in the previous, here when we apply the force, what happens? The viscosity is going to decrease in pseudoplastic flow, but here in this case, in the dilatant flow, when we apply the stress or force or shear stress, the viscosity is going to increase. Okay, so when we can see this type of flow means when the liquid is mixed with starch, that is concentrated starch suspension. Okay, so in the diagram we can see, so here there is a less viscous liquid, we are applying the force. What happens? The liquid is more viscous, that is viscosity is going to increase. And here Rheopexy means it works opposite to Thixotropy. Here the viscosity increases with the time and when the shear is applied. Means these are the solutions. Here the viscosity is going to increase, which is when we are applying the stress or force to that liquid. Example for this category is lubricants and gypsum paste. What are rheograms? So it is the graph between the shear stress and shear rate. What are rheograms? So it is the graph between the shear stress and shear rate. Pharmaceutical applications of rheology. So this concept or this knowledge is used in the preparation of suspensions to study the physical stability, and in emulsions consistency of emulsions, then in preparation of ointments, and spreadability of semi-solid dosage forms, and in preparation of syrups, and pourability property of syrups, then in preparation of injectables, then in the manufacturing processes like mixing, pumping, filling, etc.